Immunoblotting combines the superior resolving power of SDS polyacrylamide gel electrophoresis with a highly sensitive antibody binding assay to detect a specific protein in a mixture of different proteins. Proteins are first separated in an SDS polyacrylamide gel. Then, in the blotting step, the proteins are transferred to a sheet of nitrocellulose membrane. The gel containing the separated proteins is placed on the membrane. Proteins are transferred from the gel to the membrane by electrophoresis. In the electric field generated by a power supply, the proteins coated with negatively charged SDS migrate toward the positive electrode. As the proteins migrate out of the gel, they are captured on the membrane because nitrocellulose binds any protein that contacts it. The proteins stick to the membrane in the same relative positions they had in the gel. The transfer of proteins from the gel to the membrane is called blotting. Unlike the gel, which is fragile and thus difficult to manipulate, the membrane is stable and is well suited for the subsequent steps. The gel is discarded, and an inert protein such as serum albumin is then used to coat the membrane so no other proteins will stick directly to the membrane in subsequent steps. A primary antibody, chosen to specifically bind only the protein of interest, the red one here, is then added. The albumin coating keeps the antibody from sticking to the membrane. After a washing step, only the primary antibody that is bound to the red protein remains. Several methods are used to detect the antibody-labeled protein. All use a secondary antibody, which binds specifically to the Fc domain of the primary antibody. Most frequently, an enzyme linked to the secondary antibody catalyzes a chemiluminescent reaction. The light generated is detected by film or by a two-dimensional detector, permitting the identification of the location of the protein of interest.